Welcome to Easy Limu Learning Simplified. My name is Eric. I'll be taking you through this topic, coordinates and graphs. And for this particular lesson, we're going to cover something on plotting of points given, points on a Cartesian plane. We want to see what's all about plotting and how do you plot points when you're given when you're given the respective points when you're given particular points, and then you need to plot them on a Cartesian plane. How do you go about it in general? So we have a few questions to help us with illustrations on how we plot points on a Cartesian plane when you're given points or when you're given the coordinates, coordinates of certain points. Previously, we looked at how you can extract the coordinates of a given point on a Cartesian plane. Now we want to do the reverse of that, which now involves plotting certain points when you are given the coordinates of those points, and then you're supposed to locate them on a Cartesian plane. And then, of course, at the end of the lesson, we'll give you some questions in the form of assignment to help you with practicing and just to help you check on your understanding of the concept as discussed during this lesson. So we already mentioned in the previous case that the positions of points on a plane can be located using ordered pair coordinates, where we say the x coordinate comes first and the y coordinates come second. So the first number, of course, represents the distance along the x-axis. That is the x-coordinate. So the x-coordinate will simply mean the number of steps along the x-coordinate from the origin, that is to the positive side or to the negative side. The second number is the y-coordinate and represent the distance along the x-axis on either side, either the positive side or the negative side of the y-axis. So we're talking about y-coordinate. So the x and y-axis or axis, they intersect at a point origin where the x-coordinate is 0 and the y-coordinate is also 0. It's called the origin. So let's see, we want to plot the given points. Point 0, 0 already, of course, that we've said is the origin. Remember, all the movements must start from the origin. So if the coordinates are given as 0, 0, it simply means that while at the origin, no movement along the axis, along the x-axis, there is also no movement along the y-axis. So you'll use a small star to locate that way, and then you call it point A. Then so you can maybe indicate even the coordinate 0, 0. Then point B is 4, 0. So 4 is the x-coordinate, which represents the number of steps along the x-axis from the origin, and because it's positive, we are going to move to the positive side of the x-axis. So 1, 2, 3, 4. Then y-axis 0, no movement, so you stop there. So that is the point B, 4, 0. This other one was 0, 0. Then you move to point C, which is now 4, 6. So you move 1, 2, 3, 4. Then vertical axis 6 to the positive side. So 1, 2, 3, 4, 5, 6. So which point is that? C. So 4, 6. Now, we are told this is a rectangle. So for it to be a rectangle, now, then it simply means then. So first of all, you join the points that you have plotted first to see how it's going to form a rectangle. So we start with that. So you can complete the rectangle. The rectangle has got a special characteristic that the opposite sides are equal in length. So that is equal to that. And the opposite sides are also perpendicular to each other. And each of the interior angles are 90 degrees. So that is the rectangle. And therefore, the point D can only be here. Yes. So because you've looked at the coordinates, this one will be read as 0, 6. No movement along the horizontal axis, then you move 6 steps upwards. So we have again three vertices of a parallelogram, P, Q, R, S, R. Now this one is a parallelogram. So we have the first point P, -4, -4. So -4, the first coordinate is -4, meaning 4 steps to the negative side. So -4, then -4. So -4 along the y-axis, again you move downwards. See, that is point what? That is point P. So point P is -4. So yeah. So point P, -4, -4. Then Q, -3 again, -5. So that is too close. Maybe let me talk of -1 here. So -3, -1. So -3, -1 would be somewhere here. That is Q. And then R is -3, -2. So -3, -2, maybe we change this to +2. So -3, let me change this one also to 3, 2. So 3, 2, you move this way. So this is R3, 2. You see. So then you're supposed to complete it so that you end up with what? Parallelogram. So let's join and see. Okay. So this one, for it to be a parallelogram, the parallelogram opposite sides are parallel to each other, then it means point S can only be here. This is where point S is, and it's going to be 2 steps along the x-axis and -1 step. See. So 2 steps along the x-axis, positive and then -1. Yes. So take note, as we plot, we start with the movement along the x-axis, then movement along the y-axis. Very, very, very important. So we have a few questions here to help you practice on what we've been learning through this lesson, how to do plotting when you are given the coordinates. So we have a rectangle with coordinates -1, 3, 4, 3, 4, 0. You're supposed to find the last vertex. Then we have triangle. You're supposed to find the last vertex, or basically just needs to draw the triangle on a Cartesian plane. That means you'll have to plot the point, and this point, and then you need to join those points to give you a complete figure, which is a triangle. The same applies to the parallelogram, similar to the one that you have just done. You plot the points, and then you should be able to join them in such a way that you're ending up with a parallelogram, and that will be able to help you find the last value, the last coordinates for the point D, as we illustrated during the lesson. Otherwise, that is all for now. Till next time.